Quantum computers are racing toward commercial reality, and an entire supply chain is being built to power them. This is the quantum computing investing stack. From the machine builders down to the lasers, refrigerators, and chips every system depends on. At the top sit the superconducting qubit builders, who cool tiny chips to near absolute zero and control them with microwave pulses. IBM leads here, and its 1121 qubit Condor, revealed in December 2023, was the first to cross 1,000 qubits. Google pushes its own superconducting roadmap, and Rigetti builds full-stack superconducting machines as a smaller public player. All of them lean on dilution refrigerators and well-established semiconductor fabrication, which ties their progress directly to the deeper layers of this stack. Next comes trapped ion hardware, where charged atoms are held in place by electromagnetic fields and manipulated with precision lasers. IonQ is the established pure play in this approach, prized for the quality and stability of its qubits. Honeywell controls Quantinuum, the heavyweight built from its ion trap business, which priced its Nasdaq IPO on June 3, 2026, at $60 per share for 28 million shares, under ticker Quant, raising about $1.68 billion and debuting the next day above a $15 billion valuation. This layer covers annealing and specialty machines, purpose-built for optimization rather than general computing. D-Wave is the pioneer, and its 4400-plus qubit Advantage 2 annealer reached general availability in May 2025, giving companies a working tool for complex optimization problems today. Google is also exploring neutral atoms as an alternative path, and Infineon became the first public neutral atom pure play after its February 2026 New York Stock Exchange debut, opening up a fresh modality for investors who want exposure beyond the dominant superconducting and ion trap approaches. Photonics offers a different bet entirely, using light to compute at room temperature instead of relying on bulky dilution fridges. Xanadu became the first pure-play photonic listing in March 2026, betting that light-based qubits can scale more cleanly. Alongside it, small-cap quantum computing pursues photonic systems and components. The same layer leans heavily on laser and photonic chip suppliers like Coherent and Lumentum, whose optical hardware feeds directly into these machines. Room temperature operation is the dream here, removing one of the biggest engineering burdens facing every other modality. Every quantum workflow today is actually a hybrid one, pairing quantum processors with classical computers, and that is where NVIDIA plays. Its CUDA-Q platform and NVQLink connect GPUs to quantum processing units at microsecond latency, handling the heavy lifting of error correction and calibration that quantum hardware cannot do alone. As quantum systems grow, the classical co-processor side scales right alongside them. Even annealing players like D-Wave are layering gate model development on top of their existing business, reinforcing how tightly classical and quantum compute are now intertwined. Here we hit a hard choke point. Quantum hardware needs refrigeration close to absolute zero, and that market is a duopoly held by private firms Bluefors and Oxford Instruments. Worse, these fridges depend on helium-3, a tritium decay byproduct so scarce it trades near $2,500 per litre. The supply is so tight that Bluefors signed a lunar mining deal running from 2028 to 2037 with Interlune. Because the leaders are private, listed exposure comes only through industrial gas proxies Lind and Air products, making this layer both essential and remarkably hard to access. This layer is the control and measurement electronics, the racks of gear that translate software into the exact microwave pulses qubits respond to. Keysight is central here, and its quantum control system is embedded in the Fujitsu and Riken 256-qubit superconducting machine at their collaboration center in Japan, announced in May 2025. The system has spread across academia, national labs, and commercial quantum companies since its February 2023 launch. Adjacent test and measurement exposure comes from Teradyne and Emerson, both deeply experienced in precision instrumentation. Beyond control electronics, Qubits need specialty optics, lasers, single photon detectors, and photonic integrated circuits to trap atoms, read out ions, and route photons. This optical supply chain is critical across nearly every modality. Listed exposure runs through coherent and Lumentum on lasers and photonic components, and through IPG Photonics, a leader in high-power fiber lasers. Japan-listed Hamamatsu dominates single photon detection, supplying the ultra-sensitive sensors that make quantum readout possible. Without these precise optical tools, ion traps and photonic systems simply could not function at the required level of accuracy. At the foundation lie the picks and shovels. Global foundries and TSMC fabricate the qubit and control chips that everything else rides on. Amazon and Microsoft resell quantum time through their Bracket and Azure quantum cloud platforms, putting hardware in reach of any developer. Intel pursues its own silicon spin qubit path, leveraging its chip-making expertise. And Palo Alto Networks sells the post-quantum cryptography migration that every enterprise will eventually need as quantum machines threaten today's encryption. This layer turns quantum from a lab curiosity into accessible, defensible infrastructure. These names are deeply interconnected, from foundries and fridges to the machine builders on top. Stack Maps lets you see the whole stack at once and get signals on the news moving each company. Follow Stack Maps across socials to keep exploring the stack.